In this quick take video, we're going to talk about how to implement Xilinx MIPI D-PHY solutions and some of the options that you have for D-PHY. Here's the agenda for the quick take video. First, we're going to go over how to find more information on MIPI, where to look to go find that information. Next, we'll talk about how to implement Xilinx MIPI D-PHY solutions. We'll talk a little bit about the MIPI D-PHY electrical portion in Xilinx devices. We'll go over how to run a MIPI TX high-speed hardware simulation with an IBIS model, and then we'll wrap this up with a summary. Now we're going to look at how to find more information on MIPI. So to do that, you go to xilinx.com and simply search MIPI. So let's go look at how to do this. Search MIPI. A lot of documents may come up here. You can narrow this down by selecting the IP cores on the left. Here we have the D-PHY, the CSI2, and the DSI IP cores for more information on documentation. Now that you know how to find these MIPI solutions, let's look at how to implement the Xilinx MIPI D-PHY specific solutions. Before I fully jump into the Xilinx MIPI solutions, let's just look at a MIPI overview. So MIPI is an alliance that is a membership organization that develops interface specifications for the mobile ecosystem, including mobile-influenced industries. You can find more information on that on MIPI.org. The MIPI has alliance working groups that work to define the mobile interface specifications. There's 15 of these working groups as of September 2016. Xilinx is specifically in the camera, display, and PHY areas. Specifically the D-PHY, which has the I/O switch between this low power mode and a high speed mode, all on the same pin. So the low power mode is a single-ended, and the high speed mode is a differential. Now let's talk about the Xilinx MIPI solution. Xilinx and its partners offers a MIPI interface solution for camera sensors and display, and also the underlying PHY, which is the D-PHY. Ultra-scale FPGAs support MIPI applications through XF894, so the hardware doesn't have the native MIPI in ultra-scale. However, Ultra-Scale Plus FPGAs and MPSoCs do support the MIPI applications natively through the hardware and can support the D-PHY standards up to version 1.1, which is 1.5 gigabits per second. Going into a little bit more detail on what Xilinx supports, for the Xilinx MIPI CSI2 solution, we can support something like a camera sensor, up to 1 to 4 lanes with a clock, differential pairs. Xilinx IP can support that in Ultra-Scale Plus FPGAs and MPSoCs. We also have third-party IP from Northwest Logic available for Ultra-Scale and Ultra-Scale Plus devices. So now let's go into the IP and actually look at it. So I've got the Zinc Ultra-Scale Plus device selected. You can select any Ultra-Scale Plus device. I go in there to the IP catalog and I search for MIPI. And here I can see the MIPI CS2 RX subsystem. I'm going to go ahead and click on that. In the IP here now I can see I have different tabs for configuration, shared logic, assigning the pinouts. So you can do all this in the wizard now. There's also a link to documentation here where I can look at the product guide. Similar to the MIPI CSI, we also support the MIPI DSI display standard. The Xilinx IP can support this in Ultra-Scale Plus, and we have the third-party Northwest Logic IP again available in Ultra-Scale and Ultra-Scale Plus devices. Now similar to the CSI, let's go into Vivado and look at the IP itself. So I go back into my project and click on the DSI subsystem. Here I can see a configuration similar to how the CSI was, with my pin assignment and shared logic as well. Again, I can go over here to the documentation and look up the product guide. So this should give you now a good how-to on how to find MIPI documentation and the IP within Vivado. Here's our 2016.1's MIPI solutions for the Selectio and D-PHY. Just to mention about D-PHY, D-PHY is the underlying hardware PHY that these subsystems for CSI and DSI are built upon. That is also its own IP, and more information on that can be found in PG202. And also from the example where I went into Vivado, you can also search MIPI and you'll see this D-PHY IP show up as well. So for 2016.1, here this table breaks down the different IPs available for both Xilinx and the third-party IP from Northwest Logic. And then you can see what devices they support and the documentation examples that go along with each of those IP. Xilinx also has a MIPI reference design coming in 2016.3. This will be on the Zynq UltraScale Plus MPSoC platform on the ZCU 102 board. This will showcase the CSI, DSI, and HDMI display interface. Also will provide standalone drivers for CSI, DSI, and the HDMI. Here's a block diagram of showing what this reference design is going to look like. Let's talk about the MIPI CSI and DSI FMC hardware that can be used with the Xilinx development boards. This is designed and offered by FIDIS and InRevum. You can contact InRevum for those boards. The boards are 2 MIPI ports and can be configurable as 2x4 lane CSI2, 2x4 lane DSI, or a 1 CSI and a 1 DSI. There's also the Samtec interface to sensor module and display. There's the adapter boards for the OV13850 and the AUO display for both the sensor and display modules. Again, those can be ordered through FIDIS and InRevum. This hardware is all planned to be used for a reference design that was just talked about previously for 2016.3, which is really going to showcase the MIPI CSI and DSI. Now let's spend some time and talk about the MIPI D-PHY electrical. So the MIPI D-PHY has a specific I/O standard called MIPI D-PHY DCI. This is only available in UltraScale Plus, FPGA, and MPSoC devices. It's only available in the HP banks, so it cannot be used in the HD banks. This I/O standard requires DCI and the 240 ohm external resistor on the VRP pin, like you would be using DCI on any other I/O standard. The I/O standard also allows diff term and slew rate options. The output termination here is always on. It's actually dynamic and will switch between the high speed and low power mode. The table here shows the allowed attributes for the MIPI D-PHY DCI standard, and you can find more details on that table in UG 571. Let's look at how to run a MIPI TX-HS hardware simulation using an IBIS model. So here's the IBIS model for the high-speed TX simulation, and we're going to only simulate HS in this case, and I narrowed it down to a transmit. So this might be like a DSI type of interface. So we've got the FPGA modeled here. We've got a PRBS pattern generator. I've got the generic MIPI HS receive termination here, and then a generic PCB transmission line. So this is what makes up the IBIS model. Now let's look at the IBIS simulation. So here we're going to look at the driver under typical conditions. We've got the 1500 megabits per second speed, and this is using the MIPI IO specific standard. Here you can see the different trace lengths that I used to show the driver under different cable length conditions. The next couple simulations I'm going to show are under different type of conditions, but everything else will stay the same. So the speed will be the same, and I'll show the different cable lengths here to show the different simulations, just under maximum and minimum and typical configurations. So here now we can see the minimum conditions, and you see the waveforms opened up maybe slightly. Again, it's at 1500 megabits per second. And then finally here we've got the maximum conditions. So you can see here that the eye has closed a little, and the further distance you go, it closes just a little bit more. But really this is to showcase the nature of how robust this driver is for MIPI. Let's summarize what we've seen in this quick take video and wrap this up. To find more information on documentation, go to Xilinx.com and simply search MIPI. You can narrow this down if you want to look at specific IP cores, as we saw in the demonstration. You can narrow that down on the left-hand side by clicking IP cores. If you want to see documentation or answer records, those options are there too. MIPI describes the mobile interface specifications, where Xilinx specifically supports the D-PHY, CSI, DSI through the Selectio, and those are the different MIPI working groups as we talked about earlier. We offer this available through IP. We have the Xilinx IP and the third-party Northwest Logic IP. So how to find Xilinx MIPI solutions. For UltraScale, those solutions are specifically through XApp 894. For UltraScale Plus FPGAs and MPSoCs, the solutions are now through the Xilinx IP, since we support MIPI natively in UltraScale Plus devices. Documentation there is listed the PG202, PG232, PG238. Those are the documentation for the IP, and those are ones we searched for and found on Xilinx.com. We also offer the third-party MIPI IP from Northwest Logic, and that's available for both UltraScale and UltraScale Plus, but that solution is going to require additional external components. Finally, we looked at how to run a MIPI IBIS simulation, doing a transmit high-speed type of IBIS simulation that might model a DSI type of display interface. We looked at the typical minimum and maximum simulation cases with a PRBS pattern. So this should give you a good overview now of what solutions Xilinx offers for MIPI and where to go and how to find more information. Thanks for watching.